Okay, so this is lesson 11.6, and it deals with a lot, basically everything we've done in Unit 11 already. It's just kind of all blended together. So on this first part, they want us to determine if the sequence is arithmetic, geometric, or neither. And if it is arithmetic or geometric, write an explicit formula to find the nth term, then find a sub 7. So let's look at the first one here. Notice that, let's see, they're going from there to there. They'd have to multiply by -3, and then times -3 again, and times -3 again. So that tells me that it is geometric. And then our formula would be, this is coming from the last test, okay, a sub n would be the first term times -3, n minus 1 times. So this would be the first answer, because that's our formula. And then to find the seventh term, we would say the seventh term is the first term times -3 6 times. And that's just simply plugging it in your calculator, and you should get this. Okay, so actually there's 3 answers on that one. All right, on number 2, notice this one is awfully weird. You're not multiplying by the same thing each time, and you're not adding the same thing each time. So this is one of those strange ones that you would just say this is neither. And if it's neither, you don't really have to do anything else to it. You're done with it. Okay, and number 3, notice here, let's see, what are they doing? -9 each time, right? Yes, so that means that's arithmetic. Okay, so there's that one. So that formula, if you remember from the last test, it's first term, and we have to subtract 9, n minus 1 times. And you can just leave it just like that. Then the seventh term would be the first term minus 9 6 times. And if you plug all that in your calculator, you should get -1. Now, we didn't do these other ones in that section in class because everybody felt like they knew this since it was all tested before. So I just posted the answers for you on Plus Portals, so you can kind of do a few if you feel like you need it. In the meantime, we're going to go on to the next little section. This one has the series, so it's a little bit different, but very, very similar. But this time they want us to find the indicated sum. And you still have to tell if it's arithmetic or geometric. So notice, let's see, each one in this series, they are, what is that? They're adding 7 each time. So if I want the sum of the first 19, then this would be 19 divided by 2, first term, plus the last term. But notice they don't give us the last term. So that means I got to go use my formula that we did on this first section up there. The last term would be the 19th term. So that would be the first term plus 7 18 times. And that gives us 144. So once I find that, I can plug it into my formula for the sum. And then, of course, do all the math on that one, and you get 1539. So the thing is, you got to recognize when it's arithmetic, when it's geometric, and then which formula to use. So you need to know the formulas. Okay, so number 10, let's see, this one. Looks like they're multiplying by -5 each time, and we want the sum of the first 7. So sum of the first 7. Since we're multiplying here, this is different. This is a geometric one. Well, let me put, this one was arithmetic. This one's geometric. The 7th one would be the first term. And then you've got 1 minus -5 7 times over 1 minus -5. So you got to be real careful how you plug that in your calculator to make sure that you're getting the right answer. Sometimes, it's easy to put the parentheses in the wrong spot or whatever and get a wrong answer. So you do want to do the math on the calculator yourself just to make sure you got it. And you should get that number there. Okay, now for this section right there, those few 11 through 14, we didn't do those in class. I have the answers posted, so if you want to do a few, just make sure you got it. Basically, it's the same thing that we just did on those two. Then in class, we looked at these, and everyone liked these because whenever you have the notation, that summation notation with the sigma, you can essentially just plug that in your calculator. So if you remember from yesterday's lesson, you could type in, there's a button on your calculator that says math. So go to math and 0, or just tab down to the last one, I think, and it gives you that summation notation. You can just plug everything in and get an answer. So the kids really liked it. I'm not going to make you do it the long way and write everything out like that. So on this one, you should get negative 1792. And on number 16, you get negative 40,955. Now, the only difference is it asks you also, is it arithmetic or is it geometric? How can you tell when you're just plugging it in? Okay, so this one right here is arithmetic, and this one is geometric. So what I'm wanting you to notice is that on the geometric ones, you're going to have the exponent be a letter. Okay, that's your variable. So that's how you'll know. This is negative 5 times 2 to the whatever power. So that is your geometric. The other one, when you're just multiplying by regular number there for the variable, then that is arithmetic. So you can check those. Now, 17 and 18 are the same. But notice the difference here on number 19 and 20, because you see how we got to go to infinity? Well, you can't just plug that in your calculator. If you can, I haven't figured it out. So if you do figure it out, you be sure and let me know. So what you have to do is use the formula for that. Notice both of these are geometric, okay, because it has the power here. That is a letter. So the formula here, you're looking at whenever it's got the infinity, you check to see if it has a sum. Sometimes it doesn't, sometimes it does, okay? If this r, this is our r right here, what has the exponent, if the absolute value of r is less than 1, like this one is, then we know it is convergent, and it does have a sum. So we can use that formula. We're saying, well, the sum would be the first term, which is your negative 7/4, that's the thing right here. And then you would have in parentheses 1 over 1 minus r, and r is negative 1/5. And then you got to be real careful, again, plugging this in your calculator. Why don't you do that and make sure you can get negative 35 over 24. On this next one, notice the r, in this case, the absolute value r, is greater than 1, because 3/2 is 1.5, which means this is divergent, and it has no sum. Okay, it kind of goes on to infinity. So there's no way to, it's not converging on one particular number. It's not getting real close to one particular number. So that is only the ones with the infinity on top that you have to worry about which one is which and what you're looking for there. Okay, on this next page is all word problems. You know, that's the biggest thing. That's what most people kind of struggle with. So these are all mixed up together. So notice on our first section here, these are all sequence ones, which is basically stuff we've done before. So when we look at this, it says a library book's 1 day late is charged a $1.95 fee. Each day thereafter, it's charged an extra 20 cents. Find the fee for a book that's 35 days late. Well, I know the first day it's late, it's $1.95 plus 20 cents each day after, and that would be 34. So notice that's our formula for arithmetic. Your first term plus your common difference n minus 1 times. So that gives us 875. So pretty straightforward. We did these before. That was on the last test. Number 2, Tucker took an 800 milligram dose of medicine for his headache. The table to the left shows the amount of medicine remaining in his bloodstream after each of the first 3 hours. After how many hours will the amount of medicine reach 50 milligrams? Okay, so this one's a little bit different. Because it's an R one, isn't it? Yeah. Because notice it's going down here. If we divide this out, what are they multiplying by here? 0.85. They're multiplying by 0.85. And if you're not sure how to figure that out, just take the second term, which is like 680, over the first term, and just divide that out, and that'll give it to you. That's how you figure out. And just double check to make sure, because that should be the same as, say, 578 over 680. You know, you can just make sure they get the same thing, and you'll know it is the R, because the R has to be the same. All right, so let's see. We want to know how many hours will Mount medicine reach 50 milligrams. So 50 is the ending 1, beginning with 800, and we're multiplying by 0.85 n minus 1 times. So we've got to solve that particular formula. That should be fun. So if I divide by 800 on both sides and simplify this fraction, I get 1 over 16 equal to 0.85 to the n minus 1 power. So what we need to do now is take the log of both sides. And you could do log or you can do ln. It doesn't really matter. I usually do ln just because it's one less letter I get to write. So if I do the natural log on both sides, then I can bring that n minus 1 down. Okay, so I'm going to work it up here. So this gives me n minus 1 times ln. Here, I'll try to write the steps on this one. Equal to ln of 1 over 16. Then I can divide by the natural log of 0.85. And then, of course, to get n by itself, I do that in my calculator and then add 1. And I believe you get about 18.06. And, of course, this is word problem, so you should always put your units. So 18.06 hours. So notice it's very similar to number 1 and number 2. Just on number 2, we were solving for n, the number of months, or hours, rather, I should say, not months, hours, instead of actually looking for the number in the sequence. Okay, so now we go off to the series ones. Okay, on the series ones, it is talking about sum, and we know that because this word total right here. So we're talking about stocks at a company were $9.80 per share. Value of the shares has increased by 25% each year. If Ari bought 20 shares each year since they were issued, find her total investment. Okay, so let's see. The total investment for 15 years would be your first term. What is our first term? Let's see, it's $9.80 per share, and she bought 20 shares. So 20 times 980, that was 196. And then that would be 1 minus the 25%, and it's increasing, so that's 1.25 to the 15, because it's 15 years, over 1 minus 1.25. Again, you just got to know where these numbers come from and the formula. So if we plug all that in our calculator, you should get 21,498.62. So if it's money, make it look like money. 2 numbers after the decimal, all that good stuff. Evan got a job, starting salary of $36,000. He gets a $1,500 raise each subsequent year. How many years will it take for his total earnings to reach $1 million? Okay, so total earnings means the sum. So he's not getting $1 million in 1 year, obviously. So what is the sum for $1 million? Like how long? So we're solving for n here. So we know $1 million would have to equal n divided by 2 of, let's see, the first term, which is 36,000, plus the last term. Well, golly gee, they don't tell us what the last term, because we don't know what n is. But we do know that the last term can be found by taking the first term plus the d, which we know is 1,500, n minus 1 times. So notice all that in blue right there is our last term. So now, even though it looks ugly, we've got one equation with one variable. We can solve this. we can figure it out. So the first thing I'm going to do is multiply by 2 on both sides. And then let's see if I can do this at the same time. I don't know, maybe I should write this down. Okay, I'm going to combine all my like terms. I'm going to say 1,500 in, and then minus 1,500, and then add all the numbers together. So this gives me 1,500 in plus 72,000 minus 1,500, 7,500. Okay. Then I'm going to go ahead and distribute that into these two pieces and subtract the 2 million on the other side at the same time to try to save me some steps of writing, because they didn't give us a lot of room on this page. That's a lot of zeros, y'all. Okay, but I'm noticing that if this one has 2 zeros and this one has 2 zeros and this one has 2 zeros, I can take some of them zeros off just to make the math a little bit easier. And at this point, I don't even want to attempt to factor this, and I don't know that it will. So I'm going to go straight to the quadratic formula. So this would be negative, actually, you know what? I think I did it without it, but negative 705 plus or minus, because it's negative b, plus or minus square root of b squared minus 4 times a times c all over 2 times a, and I ended up getting n to be about 19.92, but whatever, and that means about 20 years. There we go. So sometimes they're not pretty to solve, but they're doable. Okay, let's look at number 5. This one says, notice we got mixed applications. So you got to figure out what it is that they're asking you to do, and they're all mixed up. A ball is dropped from a tower. The table shows the height of the ball after each of the 3 bounces. Find the height of the ball after the 12th bounce. Okay, so this is down 5, but that's not down 5, so I know it's not subtracting the same thing each time. So if I say 45 over 50, 0.9. Okay, so that means our 12th term can be found by taking the first term times 0.9 11 times. So you get 15.69, and of course this is feet because that's in feet. Okay, so number 6, logs are stacked, so there are 40 logs on the bottom row. So here's our bottom row, 40 logs. Next row, each row after has 2 fewer logs. So like this one would be 38, the next one would be 36, and so forth, right? And the top row is going to have 8. So all the way up here we're going to end up with 8. Find the total number of logs in the stack. So total number of logs, so that means the sum of all the logs. The only thing is we don't know how many rows it is. So I can't do that yet. So first I gotta figure out how many rows that is. So let's see, the last term is 8. That would be equal to the first term, which is 40, minus 2 n minus 1 times. So I can use that equation to find out how many rows it is. So it's negative 32 by subtracting 40. Now I'm going to divide by negative 2. So 17. Okay, so there are 17 rows. So n of 17. First one is 40. No, I don't need that yet. That's not what the formula says. I have to first say 17 divided by 2, right? And then it's the first one plus the last one. So how many logs is that? 408. Sweet. All right, let's see. When Michelle brought her newborn son John home, he slept just 3 hours the first night. Each night thereafter, he slept an extra 5 minutes than the previous night. How many nights will it take John to sleep an 8-hour stretch? Okay. So 3 hours, but then this is extra 5 minutes. So I'm going to take that 3 hours and write it as minutes. So 3 hours at 60 times 3, that's 180. So 180 minutes is what he slept the first night. And then like the next night would be 185, 190, so forth. and we want to go all the way to 8 hours. 8 hours is 8 times 60, so that's 480 minutes. Okay, so we want this long. So let's find out how much that is. So 480 would be equal to 180 plus 5 n minus 1 times. So subtract 180, divide by 5, add 1, so 61, n is 61. So 61 nights. That one's not too bad. All right, in class we did get to number 8, but then we didn't do 9 and 10. We're going to do that on Monday. So Elijah started a new Instagram account, gained 8 new followers his first week. Each week after, he gained twice as many followers as the previous week. What's the total followers Elijah has after 16 weeks? Okay, so we want to know the 16th term. Now, here's what got me. When I first looked at this, I saw this word total, so it messed me up. But then I realized that when they're getting twice as many, that is his total, because the person's not being counted twice. So the 16th term can be taken the first term times 2 15 times, and that gives you 262, 144. All right, so we still got 9 and 10 to do, but we're going to do this in class on Monday, and hopefully you'll be back by Monday.